Hey, what's up, AP Stats team? How's it going? We are on test unit 3. I'm going to do it in a different place today. Usually I do it up in the living room. I'm going to kind of give you just a little bit. I'm going to turn this off too. You're hearing my background on that as well. But I wanted to just give you the heads up. This is the hacienda here. This is where, right over there. That's where I'm going to do the study session right over there. I got a little couch over there, a little wall, watch the Michigan games on. Loving it down here in the basement today. And we're going to get this thing underway here. All right, we're going to just hop right into it. And I see that we got one viewer in the house. And I've got a lot coming, I know. Sweden followers, anyone from out of country who is listening, thank you for coming and listening to my podcast, and so I appreciate that. So real quick, one thing that I want to do that we kind of started last time was this idea of putting in different questions that you have before we kind of get underway and get started. I've got 5 multiple choice questions too. Feel free to put those as questions. Also, there's a couple questions that I'm assigning for your review. Notice that the FRQs are not required, but I'm going to refer to those for different questions that are there. Also, if you have homework questions, we'll go over that. And really anything, just kind of a hodgepodge of different things that we can kind of go through and go over together. All right? Cool. Now, I'm glad you're here. And we are going to get this show on the road. One thing I did want to show you before I get to that Mentimeter stuff is this. Notice that on this side, turn down the music here. This right here, the correlation, context, all that. This is the concept list. One of the things that I love that Jaden, she came in my room, her and Lindsay today, and I just encourage them with is, hey, one thing to do, I think the most beneficial thing to do is get someone or get a group of people that you study with and talk through these concepts. Talk through, hey, what does it mean? What does correlation mean in context? What does R mean? Well, it refers to strength. We can tell direction. Correlation relates to linear regression, right? Things like that are things that you really want to go over and write about. And maybe you even, well, you know what I could do is if someone puts it down in the comment section, I'll even model that for you on what that would look like, even from my perspective, like what that would look like if I was a student. So if you're like, Coach, I really want to do that, just put down, hey, could you tell me how you go through the concept list and would study for this? And maybe that would be of help to you as well. But the main thing I want to go through are just some of these concept list things that y'all had questions on. And so I want to go to this Mentimeter thing. Let's see here. All right, there's your comments down there. I got you. See y'all down there. Coach Jay, yeah. Lindsay, there you are. Hello, what's up, Eric? Number 10 on the review. That's a good one. I'm going to go over numbers 3 and 10. But before we do that, can we do this Mentimeter thing? And I want to present this. So again, you want to sign in to this top side here, Menti.com with 603602. And then what are some of the questions you have on chapter 3 content? You're going to go over that. And then these are just some practice questions if you desire to do that. These are not required, but just maybe some ones that we could go over together off of. I think I put 4 questions there, or maybe it was only 3. Maybe only 3 or 4. Okay. But regardless, if you could sign in, put your questions here. I noticed that some of you already put your questions on the session side, which is perfect. I'm going to move this over here. That way I can kind of, I can look at this in that way. So I'll look at your questions and whatnot. But I'm going to do this. I'm going to go get some coffee. Got to get my voice acclimated from that first session because I know we're going to kind of fit right in. Yeah, Eric, we're finessing over here. We are finessing, and we will definitely do that. 61's a good one. I think I'm going to start with numbers 3, number 10, and then I'm going to go to 61 here in just a second. So let me get some coffee in me while you're answering the questions here, and put those questions there, and we'll be rocking. Cool? All right. Cool. I'll be right back. Good. I see some people putting some stuff up there, and we're going to, again, go through 310 and some of those questions that are on that, okay? Hopefully you're having a good day today. Hope you're having a good day. I'm trying to get this up and running. Hold on. Did I? Oh, yeah, here we are. I'm going to minimize that. Sorry, sip some coffee there and get this show on the road. Okay. Someone said something about a mini tab. Since this is already up there, before I get to numbers 3 and 10, make sure that this is first coming through. Before I get to all those other questions, let me go over just this mini tab real quick. This would be a good thing to screenshot if you're struggling with this. A mini tab would traditionally follow this format. Again, we're going to go over interpreting stuff here in a bit. And we'll go through it. But before I kind of move on, before I come back to this, this would be a good thing to just kind of remember that the constant, when we look at our y hat equals a plus bx, we remember that the y-intercept is 3.51, right? So we put that here. The b would be the slope, which would be negative 0.0034. And you put x in, and then y hat is our predictor, or y predictor, right, of the least squared regression line. And so that would be how I would get the least squared regression line from the coefficient. Again, you're not old enough to use those yet, or r squared, the ADJ, don't worry about that. So this is r squared, 60.6%, and we could get r by taking the square root of 0.606 to get what that would be. Okay, so that's how we find r. And then our s would be our standard deviation that is there. And we'll come back to all of those interpretations here towards the end, okay? Cool. Okay, so let's go to the actual questions, number 3. And man, I checked this one out earlier. This one's a doozy. And so I want to make sure we kind of go through it together here. It says this. Here's the regression equation. What percentage of the variation in GPAs can be explained by looking at the SAT scores? Well, the percent of change in GPAs, GPA is again our Y. So the percent change in GPA can be explained by looking at SAT scores. What are we asking? Well, we're really asking for is, what is R squared? What's the question? What is R squared? Because this is the interpretation of that, right? The percent of the change in y can be explained by the least squared regression line, or can be explained by x, okay? So r squared is the percentage of the change in y that can be explained by my x, or you could say the least squared regression line, right? The tighter this is, right, the tighter this scatter plot is, the closer this gets to 100%. The higher the power, right? The percent is the power, okay? I got the power. Okay, so the tighter it is would be the higher power. But if this thing's scattered out, it's going to be a lower power. The power would be closer to 0. Okay, here we go. So when we look at what percent of the variation in GPAs can be explained by looking at SAT scores, we remember that, oh, okay, hold up. I don't know my R. but I know my S of y and my S of x. Now, real quick, if I see that, S of y and S of x, that means it's the standard deviation of my y variable and the standard deviation of my x. The first thing I would do is stop and say, okay, I remember that, or I can look up on the board that the equation is r times S of y over S of x, and this a refers to my slope. You say, Coach, I've got S of y and I've got S of x, don't I? You in fact do. And I can't tell whether this, let me kind of change this up. So this would be S of y, 0.3057. S of x is 120. We don't know r, but we do know that the slope is 0.00161. Okay? And then what we can do is just plug this into our calculator here. Here we go. So we go 0.3057 divided by 120. And then, so that's times r, right? So then we get r by itself by doing 0.00161, and then I divide that by what it was there. I'm just solving this. If you're wondering, you're like, Coach, what are you doing? Well, I'm just solving this equation for r. That's it. And I get 0.632. Okay, so let's do this. R is equal to approximately 0.632. But remember, this is not r. Percent of the variation in GPAs or variation of y can be explained by x or my least squared regression line. So to get this, we've got to then square 0.632. Okay, so we got to take 0.632 and square it. And so once we take this and square it, let me see if I can square it here. Perfect. I get 0.3994. Okay, so we go 0.3994 is r squared, which is approximately, right here, C, which is 0.399 or 39.9%. Okay. Good stuff. Let's go to number 10. I did see that one. All right, so this one says, consider the 3 points. Given any straight line, can we calculate the sum of the squares of the 3 vertical distances from this point to the line? What is the smallest possible value this sum can be? All right, let me see on this. 211, 317, and 429. Okay, so first off, we know that we could plug into our calculator on our L1 and L2 list to find what the least squared regression line would be there, right? We know that. We could plug this in, get it out, and basically we could figure out what the that least squared regression line would be by going into our stat calc and rocking and rolling, right? Okay. I think the only way that we would be able to do this. Hey, what the heck? Okay, so we're gonna do this pretty quick. Okay, we're gonna do this pretty quick. I think this is good for us just in terms of calculator. So take out your calculator real quick. Go to Stat Edit. You want to delete or clear out all of your stuff. Okay, all your lists, and that way you've got it. All right. And this might just be, if nothing else, I don't know if you actually have to do this on the test, but just in case, let's go to, where's my calculator? There you are. Okay, so, let's see, 211, 317. So we have 211. Remember the X goes in the L1. 17 would be the Y for L2. Okay, let's see here. 429. So if nothing else, then maybe this allows us just to be able to use the calculator. So if these are the 3 points, if we want to find all of our stuff on it, we could go to stat calc, that's right. And we're going to go to linear regression, A plus BX, where A would end up being what the y-intercept is, and B would be the slope. Notice the r squared as well. That's the, and I want to make sure I talk over this. R squared is our power. R is the correlation. We'll talk about the official names here in a second. Don't let me forget that, because that's important. So once I do that, I can actually clear it out and go back to stat edit. And now for L3, I could actually put what the residuals would be here without actually plugging them in. And because again, what is this? Well, the L2 is the actual value because it is what is given, right? The predicted is when I take the X values of my L1 and plug them into my LSRL, my least squared regression line, and get out a Y hat for each of these values. These are the actuals. When I plug these in, that would be my Y predicted. And then I take my actual, these values, minus my predicted, when I plug these in, to get what my residual is here. So we could actually go to second stat, go down to residual. Again, that was second stat, go down to residual. And then once I do that, I press enter, and that will give me 1, -2, and 1, okay? So the question is what is the smallest possible value of the sum of the squares, right? And you might say, Coach, well, what does the sum of the squares have to do with this? Well, if I were to take 1 and square it, I get 1. Take -2 squared, I get 4, and 1 squared, I get 1. If I added 1, 4, and 1 up, I would get a total value of 6. Do you see that? So the sum of the squares would end up being a total of 6. You might say again, how did I do that? L1 is our X list. L2 is our Y list, right? X, Y. L3 is our residuals. This was good just to talk through. And then I guess my next list would just be my residual squared. 1 squared, -2 squared, and 1 squared added up equals 6. And that's why it would be A here, okay? Good stuff. Okay, I did promise I was off the homework, right? Let's do this. Let me get a little screenshot here. Let's go to HW 3.2. I want to make sure I get to number 61. I got a lot of questions on that today, which was to be expected, and I understand that. So we'll go over 61. And there's also a couple other ones that I want to hit on the multiple choice off this homework towards the bottom, and I will do that here shortly, okay? 55 off the homework. I just saw that, Brianna. I'm going in order, so I haven't forgotten about any of y'all's questions. Just hold on tight because I'm going to come around to that here in just a bit, okay? All right. Perfect. Okay, this one, here's the deal. Quickly on B. I'm going to do this one quickly. This is not on, I don't think it's on the test, but here's the deal. I just want to make sure this, I don't think this concept is. This one is just saying, suppose that the height of a randomly selected deviation below average. So if average, I don't know if it's a normal distribution, but what I do know is that for the married women, 64.5 was the mean. So if I'm 1 standard deviation below the average, that means that I'm subtracting 2.5 to get to 1 standard deviation minus 1 standard deviation below my mean. So that value, I would subtract 2.5 to get to here, which would get me 62 at that spot. The males have a similar value, except just different numbers, right? So 68.5. We subtract 2.7 going to the left to get 1 standard deviation to the left because each standard deviation was 2.7. So 1 standard deviation below the mean would subtract 2.7, and that would get me 66. I think it's 66. 65, I'm sorry. Wow. 65.8 would be that value when I subtract 1 standard deviation below my mean, okay? This one on A, that is the doozy. Okay, so first off, you on your formula sheet, it says something like this: b sub 0 plus b sub 1x. It's the same thing, just a heads up. It's the same thing as a plus bx. They just put these as the y-intercept, and this is the slope. So just as a heads up there. Now there's 2 formulas we need here. We need the fact that a is equal to r times s of y over s of x. And we need the fact that b is equal to y, the mean of y, minus b, which is my slope, times the mean of x. So if I were to kind of solve this one here, r is 0.5. The standard deviation of y depends upon this. Well, we're using we're predicting the husband's height. So the husband is the Y and the wife's is the X. So just a heads up. So the husband is the Y. So this would be 2.7 divided by 2.5. And when I plug this in, I get 0.54, I believe. I could be off a little bit, but that's how I would solve this. Then I would plug, that's A, right? So that would literally go in for this part for the least squared regression line. The B would be the Y mean. The mean for the married men is 68.5 minus 0.54 times my mean of the women, which was 64.5. And when I solve for that, goodness, I forgot about doing that. My fault. Let me get this out. All right, so 68.5 minus 0.54 times 64.5 is my spot. I got 33.67. I think that's right. Okay, 33.67. I know I went quick. So if I plug this in, this would go in for B, and this would go in for A. So really, technically, if I was writing the LSRL, I wouldn't even say Y hat. I would say men's height, okay, boom, hat, equals 30. Hold up. This should be, hold up. Did I mess that up? This should be my B, right? Because B is slope. Slope is B. This should be my A. I solved for all of them correctly, just so you know. Yeah, I just put these two incorrectly in. So A should be my 33.67. Perfect. And then plus 0.54, and this is where we would put the woman's, height. Ran out of room. Coming in your living room. There you are. And that would be what I would put in context of the LSRL. Okay? All righty. Okay, so I want to pause for just a second and see on the YouTube help where we're at, and then I'm going to go into the other stuff here in just a second. We'll go into the Menometer stuff. All right, we did question 61. We've done question 3. Yeah, so Brianna, come back and watch it tomorrow, okay? So yeah, anytime you want to, this is a live YouTube video. Come back at any time and we can do that. 55 is what I'm hearing, and then I'm going to go to the Mentimeter stuff. So I'm going to do 55, number 55 here, and then I'm going to go into our Mentimeter stuff there, okay? So 55 is backtracking. Oh, man, this is good. 55 is really good. Oh, let's do that one. Let's do this one. All right, so if you were like, Coach, is 55, is that worth it? Oh, my word. I'm telling you, I'm going to make all your dreams come true on this problem. I'm telling you right now, you're going to, once you get this one right here, you are going to be money, okay? You're going to be money for the test. This is a lot of what the test is over, interpreting, going through it. All right, so here we are. All right, so here we go. First thing, calculate and interpret the residual for the gold medal winner, Kim, who scored this, get here, scored 78.5 on the short program and 150.06 on the free skate. Okay. I'm going to try this. I'm going to try to look and see. All right, I think this is it. 50. Okay. That is Kim's, okay? So this is the point we're referring to. So I just want to make sure we know that. That dot represents the X and Y as listed at 78.5 and 150.06, okay? That's that point. Now, because that is the point, it's important to remember that that is the actual value. So if I give it to you, that is the actual value. So if I were to look at this, 150.06 is my actual Y. That's what we're looking at. The X value is 78.5, but here's the deal. It asks this, calculate the residual. So if I were to backtrack here, again, with Y being 150.06, the residual, this is like 150.06 on the Y. The residual is the distance there to my LSRL. So really what we're doing is we're taking our actual y and subtracting y hat, which is the point that's on the LSRL. Well, how do I get that point on that LSRL? We do it by plugging in my x into my equation to get what the y hat would be. What that's saying is what is the predicted value when the x is 78.5? So we could say y hat is equal to negative 16.2 plus 2.07 times 78.50. So go into our calculator here. Okay, got it here. 2.07. Sorry about that. 2.07. You could do this with me if you want to. 78.50. Get that. And then I'm going to subtract 16.2 to get 146.295. So my y hat value is 146.295. But remember, residual is equal, and I would show all this, actual minus predicted. So you say, Coach, how would you actually do this on an AP exam? I would say my actual was 150.06. Subtract, I would show all this work too, 146.295. And when I do that, 150.6, I'd get 3.765, which should make sense because it's above the LSRL. Therefore, this residual is positive, or the error is positive. So we calculated the residual. Now, what does this mean? How do we interpret this? Well, we would say that when, and this is how I would write it. Let's put context for the whole thing so we start it off right, okay? In fact, as I drink some coffee, this is what I'm going to do right here. I'm just going to do it, and then I'll come back to it, okay? So I'm going to write it out. Can see when referring to the short program score for ice skaters explaining the free skate score, we can see that all right, dot, dot, dot. All right, here's the deal. I'm going to erase this here. I'm going to do this. I'm going to come back up here in yellow. All right, so that was context. The blue part's context. Here we go. We can see that the score for Kim had a residual of 3.765, which means, here we are, this is where we go, his actual score, free skate score was higher than predicted by the least squares regression line. That's what it meant. Literally, that's what happened, right? The least squared regression line, his y, was higher than what his y hat was. Sorry about that. Sometimes I can't talk right, especially when I'm thinking it through. But this would be a really good answer for context for the whole thing, and I'm addressing the situation. That's perfect. Part B, is a linear model appropriate for this data? Yeah, it is, absolutely. So I would say, if I was doing this, so you can go back to this here, I would say, if I was writing this, I would say due to the residual plot not having a specific pattern, an LSRL would be appropriate to use with this regression. Maybe with the scatter plot, to use with, regression is fine. This regression, okay? Perfect, or scatter plot or anything like that. All right, C, how do I interpret that? Okay, so the value of C, or the value of S, I'm sorry, is the standard deviation, 10.2, okay? So remember the average distance from my mean. Well, this is the average error each value is to my least squared regression line, right? If you remember, we went back to 4.8. I'm sorry, not 4.8. That's something else. We went back to, where's my context? Here. We said that the actual Y context is whatever away from the predicted by the LSRL. So what we would say is, in this context, very kind of similar to the residual, but except it would be the average, right? We would say the actual free skate score, that's the Y context, right? Was 10.2 points. I think that's what we're referring to. 10.2 points. I'm gonna above. Well, the actual free skate score was an average of 10.2 points above what was predicted. That's what I was missing. What was predicted? Predicted is a huge part of every one of these parts here. What was predicted by the least squared regression line. You say, Coach, what is that saying? Well, it's really saying my actual score had an average error of 10.2 points above the least squared regression line. Meaning, if I took these residuals, right, and I average the residuals together here, the average distance, my free skate score, my actual free skate score was from my predicted was 10.2. And that's how we would attack it. Okay. Oh, one more. The R squared value, right? All right, so here we go. This is the percent of the change in Y, right? So that's how we started off. Percent of change in Y. So 73.6% of the change in Y. If you remember that part, I think you're going to get this. So what is Y? Free skate score. Free skate scores is accounted for by either my X change, short program scores, or you could say LSRL, okay, is accounted for by the LSRL. Let's see if I'm missing anything. I think I got that part. Just want to make 100% sure. I know that there's a couple that you could say in variability is accounted for by the LSRL. Perfect. Yeah, we got it. We're good to go. And there you are. That is 55. That is a really good question and is one that I would really look at for the test. It's a really, really, really good question. Good stuff, y'all. Y'all are answering or asking the right questions here. I do see that there's a couple of these that are off the homework on the review that I want to make sure I hit on here. Let's see here. Let's see, review session. That was lit. Well, thank you, Eric. I appreciate it. I like to think myself as finessing and being very lit in the hood. Okay, so it's just the type of guy I am, you know. All right, R squared in context, problems and mini tabs, stuff with creating LSRLs. I think I hit R squared. Here's what I'm going to do. How to calculate standard deviation of residuals. Good question. How to calculate standard deviation of residuals. Now, I will be honest, if I was to do that right now, the standard deviation of the residuals, I would say the only thing that I would do is I would go to my L3 list. Do you remember that? On my residual side, after I found my residuals in L3, and I would do my one variable statistics of my residuals. Here's the deal. You 99 times out of 100, you're not going to have to do that. I have not seen a question like that. Usually it's interpreting the standard deviation of that. But just so that you know how to do it, I would get the residuals, and then in my L3, I would find the standard deviation of those residuals by doing my one variable statistics there. Mini tab, I think I did that mini tab. If I need to go over it again, let me know. Interpreting R squared in context, we did that. 74, 76 on the homework, 7, 8, 9, 11 on the review. Okay, we're going to go through those. How do we do on, I'm trying to see here. Cool. I'm just seeing how we did on these ones here. Cool. I think y'all did pretty well on those last multiple choice there. The only one that I saw that someone missed on was 3.1, the first question, but I can always go back to that if need be. Interpreting R squared in context and 7476 on the homework. Okay. 7476. And I want to go over the review and then I can go over maybe some homework questions. Let me first look at, actually, let me look at that homework stuff real quick because I wanted to see 74. Oh, yeah. Okay. Yeah, these are the multiple choice ones, I think. 74 and 76. Yeah, I did say, I think I told Brianna, Lindsay and Jaden, or maybe Lindsay and Jaden are the only ones that I did that with. Let's look at these, and then I'm going to go over just interpreting in context. I'm going to create a list and just kind of go over and remind ourselves what we're doing there, okay? All right, so 74 says, by looking at the equation, you can see that the correlation between height and arm is what? Well, first off, can we determine this? We can see that the correlation between height and arm span is. Well, first off, the correlation, I can't say. So if I have an LSRL of X and Y, right? I have all of this points, right? All over. This LSRL that I have, let's say that this represents it. There's nothing really I can say about the correlation with this. The only thing that I can say is that what's happening with the slope. Well, since the slope is positive, we can determine that our correlation is positive, meaning it's got to be greater than 0. It's between 0 to +1, right? That's what this least squared regression line tells me. So the only thing that I can do in looking at this is I can't determine the correlation. And by the way, D should be canceled because that's greater than 1, and it's not between 1 and -1, right? So we would say that this would be, in fact, just greater than 0 would be A. Question 76, one child in the Mumbai study had a height of 59 and arm span of 60. Now, remember that what they set up on top here was that between the height and arm span, I saw something. Height is Y. Okay, so let's do that. Let's put that there. Height is Y, arm span is X. So since I gave this to you, the point of 60, 59, or my X, Y, or my arm span, height is given. Therefore, this is my actual. Like I've stated that this is actual fact. If I tell you Coach J is 6 foot tall, which is true, I am telling you that's true. Therefore, that is the actual. To find, don't laugh. I hear some of you laughing. I really don't appreciate it. I don't appreciate that, okay? Just telling you. So if I was to find what the, we have the residual equals actual minus predicted. And again, we're talking about with this part, we're talking about Y minus Y hat. That's the actual Y minus the predicted Y. That's what we're referring to. X does not really have a play on this part except to find the predicted. We have to plug 60 into the equation to find that predicted. So we say, okay, Y hat is equal to 6.4 plus 0.93. And what we're saying is what if we plug 60 into this equation, what do we get out? So we go, okay, we go 0.93 times 60. Right? I love using calculadora here. 62.2. So what we're saying is that this is 62.2 is my Y hat or my predicted value. So if this is 62.2, my actual would be my 59, okay? And because 59 is less than my predicted, we would expect this to have a negative residual, and the point of my actual, this scatter plot point, would be actually below my least squared regression line, okay? Because it's got a negative residual. So this would be negative 3.2, which would be A, okay? Negative 3.2, which is A. Again, actual minus predicted is what we're looking at there, okay? All right, let me see. Do we have any questions off of that? Woo-doo. Oh man, a lot of questions. OHM. I don't know what that means. OM? In the hood. Oh yes, in the hood. Yes, in my hizzy. Isn't that what y'all say? Hizzy? In my hizzy? All right, very good, Eric. Thanks for your help. Oh. All right. Something. Hey, Lindsay, just so you know that word you put down, it came up to me and said, do you want to post this? Because it came up as it was being vulgar. So that was kind of, Lindsay, your comment. As I'm reading it, that's pretty funny. How to display R squared in my calculator. It can be tomorrow. Yeah. Hey, Ryan, could I do that tomorrow morning? If I try to do it right now, it'd be really confusing. Or you could follow Lindsay's too. Hers can help as well. But it might be better just to look at it. Number 3 on Mentimeter. Perfect. We don't laugh at you. Thank you, Ryan. Please. Thank you. Please don't laugh, guys. Not cool. Appreciate y'all. We never laugh at you, Coach Jay. Thank you. Yeah, do this, Ryan. Well, let's talk about that tomorrow. We'll go over that before the test, okay? Remember, we have 35 minutes that I'm going to give you before the test. Get there early because the activity that I'm going to do is going to be lit. We're going to have it'll be good. I think it'll be beneficial for us. But Ivana, you're right with what you're saying there, okay? All right, Eric. Yeah, appreciate you. Eric, I feel like you support me, and I really do appreciate that. I feel like you get me like what I'm saying there, okay? All right, let's see. What do we got? Did I lose that? Where did I go? There we are. Okay, so I went through that one. I know I needed to go over some other ones off the homework, I think. Oh, yes, I know what I was going to do. Okay, this is big deal. What I would do, if I were you, I'd take some notes, okay? Let's talk about what we need to write in context, okay? First of all, you just got to state once for the whole problem in regards to what the problem is saying, okay? What is the problem talking about or saying, okay? That's part 1, okay? So in context, here are some things that you need to know, okay? First off, residual. Residual. So, Coach, what does residual mean? Residual means that the distance, it's hard when there's not a problem, and I was talking about it earlier. If I have now again, you're going to make this pretty, okay? My y-actual, okay, is higher or lower, depending on whether it's hold up, let me write it out. Then I got to write it out first. I can't talk and write at the same time. All right, perfect. Here we are. Okay, so residual is y actual, again, context, right? The actual value of y is blank. Right here, this is where you would actually put your residual amount, okay? Is blank higher or lower? If it's negative, it's lower. Higher would be positive. From the predicted number from the least squared regression line, okay? The predicted number would be like y hat, right? So just as a heads up there, that's the distance from there. That's residual there. The next thing you need to know is to know like slope, okay? Slope. And maybe it might be better if I give like an example. So let's say the residual was up here is 2.31. We would say the y-actual is 2.31 higher from the predicted number from the least squared regression line. The slope, if I had a slope of 2.31x, right? I'm just using this as an example. What we would say is that this is over 1. Then we would say for every change in 1 and then x, whatever the variable that we're talking about is, we can predict that y, whatever that is, will increase or decrease, depending upon whether it's positive or negative, right? In this case, it'd be increase by 2.31, okay? So that would be how I would predict the slope that's here. All right, so that's number 2. Number 3 would be the y-intercept. Okay, I'll keep using 2.31. I don't know why, I'll just keep using that. All right, so let's say that was the y-intercept. The point of this would be 0, 2.31. So what we would say is as x is 0, we could predict that y would be, this should be y hat because it's on the LSRL. We could predict that y would be 2.31. So that's literally what we would say is we can say when x equals 0 and whatever x is. When x is 0, just so I write it out, and this is going to be our variable, we can predict, again, predict a word again, that y will, and then right here, make sure we put context here, y will be 2.31, right? And again, this depends on context, but that's really what we're looking for with all of these interpretations. Let's think R. When I look at R and I say interpret R, what we're looking for is D, F, and S. I cannot do O because I can't assume outliers for an R. But I can say strength. If it's positive, it'd be the form would be linear. Well, the form's linear because we're using R, right? D would be the direction would be positive. If it's positive, we'll go up, right? It's negative, it's obviously negative. So that's how we would do this here. If I said, if I look at a least squared regression line, so if it's X and Y and it's got like this dots, then this would be DOFs, okay? So we would take DOFs here. Okay, so that's that. With standard deviation, so S here and R squared. This is where we want to make sure we kind of hit home here. Let's say we're talking about the pizza place. And we get the fact that the S is, let's say, 10.2, and my R squared is 88%, okay? Standard deviation is I want to make sure, I gotta write it without talking, I'm sorry. I'm going to put on average the actual and this would be context here. The predicted, and you could say this differently, but from the predicted number from the LSRL. That's better, from the LSRL, okay? Sorry about that. That one takes me a little bit just to kind of have to focus. So on average, the actual value of Y is 10.2 or whatever the standard deviation is away from the predicted number from away from the number. I like this. Let's change these two, this one and this one. Number predicted but from the LSRL. Perfect. R squared is 88% of the variation in Y, this is the context, is accounted for by the LSRL. Okay. I did that. I know I spent a lot of time on this. I just want to make sure that you understand like the context of each of these and how I can attack those accordingly. Okay. All right. I know I've got a couple other questions out there. Man, this is good stuff. Wow, a lot more comments. All right, perfect. What time's the help session start? Okay, tomorrow, I would say 7:45, Thursday, 7:30, okay? Just as a heads up. I'll be there at 7:45. Here's the deal. My classroom will be open. Come as early as you want. Feel free, come as early as you want. The best thing to do in a help session of something like that is for y'all just to talk through concepts, okay? Talk through concepts, go over stuff, okay? Cool. Yes, I have a lot of clout. That's right. All right. Okay. S can be found by putting the line equation in a calculator and then doing line ready. I think so. Yeah, Ivana, I never showed how to do the S of X there because we've never really had to do it in this class, but I think that's right. I think you can do it there. It's a good point there. Oh man, we are coming up on an hour and we are just getting started. We are going to go 3 hours longer. I'm joking, I'm messing. 7, 8, 9, 11 on the review. All right, so where are the review questions? I'm going to go through these over here. Okay, 7. All right, so here's the deal. One thing too, this is very, very important, and I don't know why I didn't remember this. In my apology, if I need to tell you what, remind me and I'll write this on the board for the test, okay? I will. R squared is the same as the coefficient of determination, okay? Termination. Remember, this is also power. So you think of power, it's like determination, like kind of, I feel like it goes hand in hand. R is the coefficient correlation. So if you see R, we've always referred to it as R or R squared. R squared is coefficient of determination. R is coefficient correlation. That's there. That's how we would solve this. Number 7. Here's what I would say to this. I don't like it because it's asking for what the R squared value is. And really, to be honest, when I look at this, I could see 2 answers. These are really, really tight. First off, I would find what is my R approximately. I would say my R is anywhere from 0.8 to 0.9-ish is what I would say because it's really, really tight. So I would say that if I did R squared, if I squared 0.8, I would get anywhere from between 0.64 to 0.81. Okay, so if I looked at this, there's really 2 answers that I could see myself answering. Answer D or answer B. All the other ones, I wouldn't answer those. Those wouldn't be there. But they wanted you, when I looked back at this, because someone had asked me about this earlier, they wanted you to put all of these points in your calculator, which it's impossible to see the actual points. Now, if they give you a list, plug it in, get your LSRL, and then it'll give you your R squared value, which you can then interpret here. But overall, I'm literally, I would just say, know that it's tight. It's probably between 0.8 to 0.9. That's important to be able to identify that. And then know that how to change R to R squared. That's all I need from you on number 7. Cool. Number 8, it says, with regard to regression, which of the following statements about outliers are true? Outliers have large residuals. That's true. A point may not affect the regression equation, even though its x value is displaced in the x direction and its y value is an outlier in the y direction. A point may not affect the regression equation, even though its x value is displaced. Not affect the regression equation. All right, I'm going to come back to that one. It's wordy. 3 is removal of an outlier will affect the regression line in a meaningful way. Yeah, that's true. That's absolutely true. So I know 1 and 3 are absolutely 100% true. So I would be between this one or this one. Okay, so either B or D. So when we look at the second one is a little weird. It's just wordy more than anything. The question that that we're looking at is, the second one's just weird. And I don't really like maybe the wording, but it says a point may not affect the regression equation. Affect. It's displaced in. It's really wordy. I'm thinking that it means if I displace, this is what I'm thinking. Okay, so I'm sorry. I'm thinking that this one's false. Okay, because if a point on this is displaced, x value is displaced in the x direction, and its y value is an outlier in the y direction. So this y, if it's like, what? it's like up here and it's displaced, it would affect, if it gets displaced left to right, it's affecting the LSRL, right? If I took an outlier up here and it was displaced right or left, it's affecting it. I'm going with B. I'm sorry, that second one. Good gosh, that's pretty bad. My apology. I should have gotten a different question. That was a bad one. The next one is number 9. All right, number 9. As reported in the Journal of the American Medical Association for study, following tabulation show a measure of strength versus a measure of functional mobility. What does the slope of the LSRL signify? Okay, so I don't know what the LSRL is. I would put this into L1 and this one into L2. When I do that, let me see what my answer sheet says here. Oh, I didn't even put down. I got that it was negative slope. So the negative slope. So it would be either, it's not A and B, it's either C or D. So let's see, signifying the relation between strength and functional is weak. Well, the fact that it's a negative slope does not mean the relationship's weak. It just means it's a negative slope, right? Negative correlation there. So this one, the sign is negative, signifying that the greater the strength. So as strength increases, which is my X, is that my X? I didn't even see. As strength increases, yeah, that's my X. As strength increases, the less the functional mobility. Yeah, that would be the definition of what slope would be within that. So that's pretty good. Good stuff. That would be it. Number 11, find the LSRL of the data represented in the scatter plot at the right. Well, this has X and Y, right? You could actually find these points pretty easy. This is 1, 1. This is 3, 2. This is 2, 4. This is 4, 5, 5, 3. Plug those in your calculator, and that's how you get this LSRL. And then draw on the line on the scatter plot using 2 points on either extreme of the scatter plot. Yeah, so what we're saying is we're going to draw this, right? So you could get what the y-intercept was. You could also get a point on this graph as well. And then calculate the r and r squared. That comes back to when we found the least squared regression line, and then interpreting that, just like we said earlier. That would be number 11. That's how we would attack number 11 here. Cool. Man, we've done a lot, y'all. Let me go through any other questions that you've got. Yeah, Eric, I'm looking at your response here. I think it's saying if there are any outliers in the X or Y direction, then it's not affected. Yeah, that's false. It was just wordy. I agree. I agree with what you're saying. On the answer key, it says use the calculator to determine. Okay, you got it. Perfect. Yeah, good stuff, man. I'll tell you what. Y'all are awesome. I love AP Stats. I really do. Even at home, I'm at home chilling, and I get to do AP Stats for like, what do we do now, for an hour and 2 minutes. That's awesome. I really do. I appreciate y'all. Love y'all. Y'all have worked so hard over the course of this unit, and I know that your preparation is gonna show up on the test. So continue to come in. There are going to be 12 multiple choice questions, 2 FRQs. For a total, I'm kind of budgeting about 55 minutes. That's why I'm thinking about 30 to 35 for that review at the beginning of class. Tomorrow, 7:45 ish, kind of depend. I've got one little meeting I want to hit, and then I'll come and help y'all out for that. Okay. Hey, I'm gonna do a new tradition. Could you do that? Okay. So here's what we're gonna do. This is my hoop, and I'm gonna shoot it out. Okay. So here's the deal. I'm gonna shoot it out. This is gonna end the podcast. So this is completely live. So and oh, by the way, and I know you're joking right now because you're like, Coach, can you actually dunk on this goal? I know that's a short joke. I can actually do it. See? Okay. So I almost missed it, which would have been really bad. All right. So to shoot us out, podcast Unit 3. Have a phenomenal day. Oh, one more. Man, I missed. Man, Man, have a great day. We'll see y'all.